Now notice we're going to be talking more about particle motion, but the big thing today is net distance and total distance. Now, if you have had a job, you know there's something different on your paycheck between your gross pay and your net pay. Yeah, your net pay is smaller, right? Oh my gosh. Now, I'm going to try to explain net distance versus total distance in terms of distance. So this afternoon, I need to go to Walmart, the one right over there. But I forgot my wallet. No, I really didn't. I don't have to go to Walmart. I did yesterday. So I have to go home, which is that way, and then back to Walmart. My total distance is from here to my house, back to here to Walmart. That's my total distance. My net distance is from where I started to where I finished. No, I started here and ended up at Walmart, okay?
So if you went to...
The graph below represents the velocity. Please, that is velocity, v of t, which is measured in meters per second of a particle moving along the x-axis. Now, let's think about this. The particle is moving horizontally, okay? What do we know when velocity is positive? The particle is moving to the right. When velocity is negative, the particle is moving to the left. So this particle is moving to the right between 0 seconds and 2 seconds because the velocity is positive. The velocity is above the x-axis. The particle is moving to the left from 2 to 7. You with me? And then the particle is moving to the right again from 7 to 10. Okay? So you got that idea. All right. Now, at what values of t does the particle have no acceleration on the open interval 0 to 10? No acceleration does not mean zero acceleration. I want you to go back to Algebra 1. There is a difference between a line having 0 slope and a line having no slope. Do you remember that? What kind of a line has 0 slope? Horizontal. A vertical line has no slope because 0 is the denominator. So what this is asking for is a of t is undefined. That's what you're being asked to find. Are there any places on that graph, and remember that's velocity, where a of t is undefined? Why 1 and 8? Oh, so you're saying that the velocity is not differentiable at those two places. Good. That an extrema on velocity is not changing direction. Changing direction is when the velocity changes sign. So the velocity changes sign right there. Give me time. Just give me time. You're right, and that's all we want to know right now. But where else? No, open interval. I can take a derivative right here. Your function, that velocity is not differentiable at those 2 points, is it? Because, remember, the one-sided derivatives have to be the same. The one-sided derivative here is negative something, and the derivative here is 0. So that function is not differentiable here and here. 1, 3, 6, and 8. So, let's see. The particle has no acceleration when the velocity is undefined. You buy that? Which means, no, V of t, no. When A of t is undefined, when the acceleration is undefined, which means V of t is not differentiable. The particle has no acceleration when the acceleration is undefined, which means the velocity is not differentiable. That's better. Which happens at t equals, what do we say, 1, 3, 6, and 8. Be thorough in your explanation, but don't write novels. No. I mean, you could say because there's a cusp, but remember the graders don't like cusp. So, and see, Sparks uses cusp. I think it's fine to say V of t is not differentiable at those points. I think that's fine to say. Okay, express the acceleration as a piecewise function. As a piecewise function on the open interval 0 to 10. Well, that ain't hard. Just consider this just any old function. What does the derivative mean? Slope of the tangent line, right? So the acceleration here on that piece, it's constant, isn't it? It's 3. Why is it 3? Because the slope of that tangent line is 3 because that piece is linear. So between 0 and 1, is that right? So between 0 and 1, it's 3. Let's go to the next piece. Let's go to the next piece. Yes, and I don't include that. No, the point. No. Yes, that's where the acceleration changed. Yes. What about the purple piece? Where we go from 1, 3 to 3, -3? -3? So between 1 and 3, it's -3. And you notice that we are not including those, quote, endpoints in there because the function's not differentiable there. Yeah, between 3 and 6, is that right? 0. And then 3 again? From 6 to where? Say again? Yes, you can. Sure. So here's what, Adam and Wendy, here's what Maggie asked. She said, since the acceleration is 3 on 2 different intervals, could I have just done this? The answer is you bet. You could do that. And then, positive or negative? -3/2 from 8 to 10. And remember, this is an open interval, so don't include 10. Now, I'm going to have to use my notes because I'm going to erase this, so I'll have enough room. We're right here. For what values of t is the particle moving to the right? The particle moves to the right when its velocity is positive. So the particle moves to the right when v of t is positive, which is, where did you say? 0 to 2 and 7 to 10. Look, you can write the word and right here. You can put a comma. They're pretty flexible about that. Where's this particle moving to the left? 2 and where? Between 2 and 7. Particle moves left when the velocity is negative, which is at or on 2 to 7. You could have said something like the particle moves left on 2 to 7 because v of t is less than 0. The wording doesn't have to be identical. All right, so far so good? Last question here. Find the average acceleration on the interval 1 to 8. Oh, use your notes if you need to from the last time. How do you find average acceleration? A of 8? V, yeah. V, it's all right, it's all right. V of 8 minus V of 1 over 8 minus 1. What's V of 8? Looks to me like it's 3, I agree. V of 1. 0 what? Use your units. Good, meters per second, because this is acceleration. Now, does that mean he was never accelerating at all? No, it's just the average over that interval. All right. Now I'm going to be very careful and write Sparks's definitions here. We've already talked about net and total distance, but let's write it up here. The net distance is the distance from where the particle object begins and where it ends. I'm going to Walmart, but I forgot my wallet, had to go home. My net distance is still just the distance from here to Walmart. Total distance is the sum of all distances in any direction. If a particle is moving the same direction the entire time, what can be said about the net distance and the total distance? They would be the same. The net distance would equal the total distance, only if you're moving the same direction all the time. Now, for this lesson, you better know where absolute value is on your calculator, because we're going to use it. To find net distance a particle travels on an interval. On the interval A to B, the net distance an object travels is P of B minus P of A, absolute value, where P of T is position. It's just the change in position, but the absolute value of it. That way, moving to the left, which is considered negative, would still be positive. You all right? Total distance. Now you notice the box is a little bit bigger. If the object, and I could say object or particle, moves the same direction, on A to B, then total distance equals net distance. Do you agree with that part? If, however, if the object changes direction, at time C, would you think about that for a minute? How would you find total distance if the object changed direction? If I forgot my wallet, I had to go from here to home, back here, and then to Walmart. I would do it in pieces. You got the right idea. You got the right idea. Well, the position, right? You got the right idea. Then, then total distance is P of B minus, let me do it this way, P of A minus P of C plus, that's me starting at school and going home, okay? But I've got to take the absolute value because technically I would be moving the wrong way. Plus home back. See if I can write that a little smaller. P of C minus P of B. There's an absolute value in there that I can't. There's an absolute value right there at the end of P of B, okay? Absolutely, it could be more than two sections.
Oh, wait.
You add the segments together. Because this is the distance between that's the distance between me and my house, between where I am right now and my house, and then this is the distance between my house and Walmart. That's the total distance I drove. Hang on. Would what be what? No, it wouldn't be 5. I'm going forward, right? I'm going backward, and then I'm going forward again. So I have 3 different pieces. Remember, velocity positive means I'm going to the right. Velocity negative means I'm going to the left. So I have 3 different pieces. Right, left, right. And Avery, Anytime I say something wrong, you tell me. Okay, we got one more question on this page. And this is, your calculator's going to come in here. The position of a particle is measured in centimeters. Find the net and total distance the particle travels from 1.5 to 4 seconds. Which one's easier to find?
Probably
Net distance will be P of 4 minus P of 1.5. All right. Now, Adam and Wendy, if you're watching this, I'm going to stop this so I can get my calculator the way I want it, and then I'll come back. Okay, we've got our equation in. What do you think the best way, the most efficient way is going to be to do this? If we go back to the home screen and we go evaluated at 4 minus evaluated at 1.5. Huh? Did I need it this time? No, because that's positive. Now, what should I have done? What I should have done, math, arrow 1 to the right, and done absolute value.
So you copy and paste that and then put it in.
Yeah. Yeah, or I could do this. I could do absolute value of answer. So, but what I need to do the absolute value first and just put all that in there. Math, right here. Arrow right once, and it's option 1. Questions? So what do we know about the net distance? Whoops. Okay. Net distance is going to be 58.75 centimeters. Total distance. What do we have to know?
When it equals 0.
When what equals 0?
E is the law.
I need to know if the velocity, I need to know if this thing ever changes direction. That's what I need to know. How do I determine, huh?
Or you can add this.
I could, but I'm going to use my calculator. Listen. X-intercepts of the derivative. Because what does the derivative represent? Help me out. What else? It's the, if y1 is position, what's y2? Velocity. Yeah. And then what would y3 be? Acceleration. Okay. So I need to know, does this particle ever change direction? And I will know that if the velocity changes sign. We good there? Now what's my interval? 1.5 to 4. I'm going to leave my y min and y max as 1 and -1, because what if the only thing I'm looking for? I'm looking for x-intercepts or zeros. Uh-oh. That doesn't matter.
You did it right. Like,
I thought I did.
Over like 4.
Oh, okay. So, we have no critical numbers. So what does that tell us about the velocity on that interval?
It does not change direction.
The velocity, so the particle does not change direction because the velocity never changes sign. So, why do I do that all the time? P of t if you looked at the position, I was gonna say, if you looked at the position function, you would see that that's always true. Okay. Since the velocity never changes sign, the particle never changes direction. So net distance equals total distance, which is 58.75, whatever it was. What was it, centimeters? Is this making decent enough sense? Next page. We got 10 minutes. We got 2 problems. All right. Listen, the longest part of these next 2 problems is just putting them in the calculator. It's not hard. It's just hitting all the keystrokes. The position of a particle is given by that function. Find the net and total distance the particle travels from 0.5 minutes to 1.5 minutes. All right, how am I going to find net distance? Yeah, just like that. Clear. I don't want that one on right now. E to the 2t minus 8t. And we're on a window of 0.5 to 1.5. Now, I'm not going to graph this, so I don't care what, I really didn't need to do that either, since I'm not graphing it right now. Mass, absolute value of 1.5 minus 0.5. Yep. You getting that? Now remember, this is position. So this is giving us our net distance, right? Round to the nearest 1,000, 3 decimal places. So we're going to say, what do we get? 9.367 feet. I'm just going to promise you this one's going to change direction. All right, so our total distance, well, I don't know yet. What am I going to have to do? Graph the derivative. This is the x value. I'm sorry, I forgot to record for just a minute. When we graphed the velocity, we found the 0 right here. So then I went back and I just typed in the x, hit enter, and it pulled up that x value. Now I'm going to store that, and I'm just going to store it in alpha A. So when I need that, I'm going to just type in A, okay? Now I'm just going to stay on this screen because I can write on it. My total distance is the distance from where I started and where I changed direction. And where did we start? What time? 1.5? 0.5. So P of 0.5 minus P of, in this case, A, plus P of that 0 minus P of where you're going to end up. Now I'm going to type that, I'm going to type that into my calculator, right there, just like that. If you type in what I've got written there, you should get right at 9.8, what did I say, 894? So our total distance, I'm not going to write this again because I wrote it on the other screen, but what do we get, 9? I do that every darn time. Thank you. 9.894 feet. Now, make sure you do write out that equation that we used, okay? When we get back from lunch, we will do one more, and that is that, okay? There you go. One more. The position of a particle is given by that function. Now, you do have to make sure you're in radian mode. Where P of t is measured in feet, find the net and total distance the particle travels from pi over 6 minutes to 5 pi over 4 minutes. I'm just going to let you work on this. If you have trouble with it, let me know. And I'll just put, yeah, you can work together. I'll put the answers that you should get, and if you have trouble, just holler at me. For those of you watching the video, these are the answers you should get. And if you have trouble with them, holler at me and I will work through it with you.